Hey guys, what's going on? Wayne here. So look, one of the recurring themes here on machine heads is tool carrier capability. It's really the single biggest factor in the explosion of growth that compact equipment has seen in the last 10 to 15 years. So recently we took a look at small articulated loaders, basically miniaturized versions of compact wheel loaders that are starting to steal share away from skid steers thanks to their compact footprint, ample lift capacities, low ground disturbance, and, you guessed it, impressive attachment support. These days, that combination of tool carrier capability and compact footprint are becoming more and more important as urban, residential, and even highway jobs place more complex layouts into spaces that are getting tighter and tighter. Which brings us to our topic today and the king of compact equipment and really the construction equipment industry in general, the compact track loader. One of the major trends in CTLs over the last 10 years or so is that as these machines have overtaken the entire construction equipment market, they have become more and more powerful and more versatile. And one of the most popular ways operators are using their CTLs more often is grading and dozing tasks. Now, because of this increased adoption of CTLs as grading and dozing machines, there are more grade control technology solutions on the market today available for these machines than ever before. And they're really designed to make CTLs better and more efficient at these grading and dozing tasks. So that's what we're going to look at here today. Grade control for CTLs. We're going to discuss why you would want to use a CTL for these types of jobs, the difference between 2D and 3D grade control, the extra equipment necessary in getting a CTL ready for these technologies, and the benefits of investing in CTL grade control for your business. Now, ultimately, the benefits come down to something very valuable, giving you time back. Let's dig in. Now, as we said before, the compact track loader is the top selling piece of equipment in North America, period. And as such, it has found its way onto just about every job site as part of just about every fleet in this region. And when you've got a machine that can do as much as a CTL can do, thanks to its deep support for hydraulic attachments, you start looking for more ways to use it when it otherwise would just be sitting around. So while dozers are more efficient for larger jobs when a lot of dirt needs to be moved around or you need a large amount of power put into the ground for deep cuts, CTLs really make for excellent light-duty dozing or finish grading. Now, CTLs are being used for dozing and grading tasks in smaller spaces like subdivisions, sports arenas, and parking lots. But they're increasingly starting to find their place on larger jobs as well, like highway construction. And that's because there are lots of situations where a dozer is too big or too difficult or it's just too much trouble to get into certain spaces. But it's also due to contractors who have a CTL who are now using it to add in base work that they might have subbed out in the past, adding that into their own business today. Now, like we said before, the CTL is the highest selling machine category in North America. In fact, according to Topcon, CTLs outnumber dozers by 8-1 on North American job sites. And even if you limit that number of CTLs, that ratio, to CTLs that are being used just for grading tasks, they still outnumber total dozers by 6-1. Now, the result is that more and more contractors have started buying larger frame CTLs instead of buying a small dozer or a small grader. Now, that results in getting a lot more machine for your money in a lot of cases. A CTL that can grade and doze, but also can dig, load, carry, trench, and just about anything else you can think of because of that attachment support, instead of a much larger machine that is really only meant for a handful of tasks, namely dozing and grading. So what has the evolution of doing this type of work on CTLs looked like? Well, in the past, contractors mostly used box blades for grading tasks on CTLs. Now, the wings on those box blades really made it easy to grab material in, pull it along with the machine, and then spread things out to grade. Now, however, Because of how jumpy those box blades could be, this setup typically required quite a lot of skill from the operator in order to reach grade effectively. Now, this not only led to greater demand and adoption of grade control technology that we're going to get into, it also led to more demand for more grading and dozing attachments, namely grader blades and dozer blades. But what about the considerations you need to make in picking a CTL for dozing and grading work, or specifically the type of CTL that you're going to need for grade control? For starters, you should ask, how much ground pressure your CTL has, how much push your machine is capable of. You also need to consider whether it is capable of supporting the type of attachment that you want to use, like those ones we just mentioned, the box blade or the grader or the dozer blade. Now, when it comes to picking a CTL for grade control systems, modern grade control systems don't require an extra hydraulic valve like they used to in the past, because they control the blade. If you're using like an automatic system, those are going to control the blade by directly connecting into the electronics of the CTL. Now, that means you're going to need a relatively current generation CTL if you're going to invest in CTL grade control that has automatics integrated in. Machines that are older than 10 years or so will likely not support that CAN bus communication that modern grade control systems with automatics require. If you're going to put a dozer blade on a CTL, you're really doing so to get rid of the wheels that the box blade had, and to give your machine really a larger blade surface so that you can make deeper cuts and really push more dirt along. And if you're going to push more dirt, you're going to need more horsepower and an overall larger machine. And CTL manufacturers have been happy to oblige in the last 10 years. In fact, not only have large frame CTLs gotten larger and more powerful, some OEMs even offer configurations now of their large frame CTLs that are focused specifically on doing dozing and grading tasks. Now, the most prominent example of a large frame CTL like this is the Case Minotaur DL550. Now, the evolution of the Minotaur as a product really is super interesting, because it really kind of started as a small dozer. And when they kind of started noticing all the similarities between, like what a modern small dozer would be and what a modern large CTL would be, it ended up being a very large CTL. Weighing in at a hefty 18,000 pounds and powered by a 114 horsepower engine, the Minotaur DL550 is very much a small dozer, but with extra CTL benefits. The Minotaur features a 6-way dozer blade with an integrated C-frame and ripper, but it also boasts a very capable loader operating capacity of 5,500 pounds. Now, this machine can hit a pile with 12,907 pounds of breakout force, and it pushes with 25,000 pounds of drawbar pull while boasting standard high-flow auxiliary hydraulics of 41.6 gallons per minute at 4,100 psi. Now, for grade control, you can get that directly through Case, and Case partnered with Leica to provide 2D and 3D grade control and total station solutions for the Minotaur. Now, let's look at what Deere has done. Now, while Case engineered a specific CTL/dozer hybrid machine, Deere's approach focuses a bit more on adding extra hardware and technology to their largest CTL. Now, the 333G is the largest CTL Deere makes, weighing in at 12,100 pounds and powered by a 100 horsepower engine. Now, Deere offers the 333G in a smart grade configuration, which adds a dedicated 6-way dozer blade, and it adds Deere's smart grade integrated kind of grade control system that offers support for both 2D and 3D machine control. Now, a similarity that the Case machine and Deere machine have is that they have these dozer modes that instantly give the operator the type of control over the CTL that you would expect from a dozer. Now, one further note for the Deere 333G with smart grade is that the smart grade system is a fully integrated machine control system, and thus it's a mastless system. As we'll explore in just a bit, aftermarket grade control systems typically require masts that are mounted to the blade on either side of the blade, and they carry laser, sonic, or GPS/GNSS receivers. Deere's 333G Smart Grade has a 6-way blade that is mastless, and that means that all the necessary receivers have been integrated into the cab of the machine itself. There are still some sensors on the blade, but most of the receivers have been integrated in the cab. Now, the plus to this is that there's a lot less stuff hanging off your machine to get hung up on stuff or broken or exposed to the elements or stolen, etc. But the downside is kind of really less versatility. When you attach grading components, to the attachment itself, that's going to allow you to swap that attachment and its grade control capability onto and off of other machines. While CAT doesn't make an official dozer configuration of one of its CTLs, it does offer a smart dozer blade with grade assist on the 289D3 and the 299D3 XPS and XE models. Now, what makes this dozer blade smart is that the CTL immediately recognizes it as a dozer blade and then morphs the machine's controls into a dozer mode, kind of similar to what we were seeing on the Case and the Deere models. It's just that this is sold as like a package that is the blade rather than a configuration of the machine. Now, CAT also offers 2 box blades and 2 smart grader blades that can be combined with Trimble Earthworks Go 2.0, which we're going to discuss shortly. Now, if you didn't invest in one of these first-party offerings, whether it be the Minotaur or the Deere 333G, or you don't have a CAT Smart, blade, if you don't have one of these offerings from the OEMs of the machines themselves, but you still want to add grade control to your existing CTL, there are plenty of aftermarket solutions available to you. Now, in this video, we're going to examine the solutions for CTLs from Topcon and Trimble. But before we do, we should take a look at 2D versus 3D grade control and really talk about the differences and when you might need one instead of the other. All right, so we're going to start with 2D. As the name suggests, 2D machine control incorporates 2-dimensional measurements, namely the height and slope of the surface that you're shaping. Now, the system delivers these measurements using laser receivers or sonic tracers that are mounted to the attachment, like we were talking about before, to those masts on either side of the blade. Now, if you're using lasers, you'll set up a laser transmitter at a spot of the site that provides a fixed plane. That laser is going to give you a fixed plane that is either level or sloped that the laser receivers mounted on the attachment are going to use as a reference for the slope that you're really working toward. You can also set up 2 of those laser transmitters, allowing the system to determine both the cross slope and the longitudinal slope for more accuracy. Now, if you're using sonic, you're typically going to have only one sonic tracer mounted to the attachment, and how that tracer works is that the tracer uses ultrasonic waves to kind of ping and measure the distance from the machine to a string line or curb or another physical object. Now, no matter if you're using laser or sonic guidance for your reference, the 2D system is essentially telling you how much you need to bring the material up or how much you need to cut out, and using that laser or sonic reference to give you guidance on the slope that you're working toward. Now, one other note about 2D systems is that they can be indicate or they can be fully automatic systems. With an indicate system, the operator is still kind of on the hook, right, for making adjustments to the blade. You're still in kind of full control of the machine. You're just being presented with the data that you need to know to hit grade, but you're still in control of the blade. And with a fully automatic system, the system itself starts controlling the blade height and tilt to achieve that grade. So one is giving you the information, the other is taking control of the blade entirely. So how is 2D different from 3D? Well, because 2D's reference is just a fixed plane reference, it doesn't incorporate the machine's position within a set of boundaries. That means that the system doesn't account for where the job starts or ends or where the machine is at in reference to the boundaries of the job site. 3D, on the other hand, it incorporates that Z-axis. It incorporates your position in the machine into the position of the job site along with the height and slope of the material. And it does that with satellite positioning provided by GPS/GNSS, or by having a total station provide a machine position reference that is kind of calculated on site. Now, what that opens up to you in terms of assistance to the operator is that a 3D system can start giving you guidance in the transitions to grade across a defined area. So which do you need? Well, it all comes down to complexity of the job. If you're working on a simple job, a flat pad, for instance, with an open sight line that just needs a cut or fill and a simple slope measurement, in that instance, 2D is really gonna be all you need. But if you're working on a job with more complexity, say a big parking lot at a strip mall with lots of features, or a new residential development that has lots that kind of step up in elevation, or taking things up a notch, a golf course that, with all kinds of hills and slopes, so one with compound slopes and different drainage areas, curb lines, trees, that is a lot of elevations and kind of grade and slope changes to keep track of, and a 3D system is going to be much better suited for that type of job. Now, could you do those jobs with 2D? Sure, but it's going to take you a lot longer. You'd also have to reset your laser each and every time you move on to another area. And not only does that take more time, it also introduces more possibility for human error when it comes to adhering to proper surveying principles and practices, making sure the height of the laser is done correctly when you're moving on to a new area, stuff like that. Because 3D incorporates boundaries in the position of the attachment really down to a golf ball sized area of the site, you can lay out an entire job into this digital terrain model and then eliminate a lot of the resetting up that you would have to do with a 2D system. Now, going 3D does require more expense. It requires a bit more equipment installed on the machine, and it requires more data prep beforehand because the machine needs to know where it is in relation to the overall plan. But 3D also brings increased productivity and huge time savings on larger, more complex jobs where you don't have that open sight line or the simplicity of kind of just like a flat pad. Now, when you do decide to add a 2D or 3D grade control system to your CTL, it does require the installation of additional hardware. Aftermarket 2D systems, the good news is that they require no modification really to the machine itself, though 3D systems do require the addition of a couple of sensors to the machine. So what are you looking at when it comes to required 2D hardware? In a 2D system, all the hardware is installed on the attachment itself. Now, like we mentioned before, the upside to this is that the attachment becomes transferable with all of its grade control capabilities between machines. Now, the first additional hardware that you're gonna have to put on a machine for 2D is that pair of masts we were talking about that typically house a laser receiver, but they can also be used to mount the sonic tracers that we were talking about. If you're using a laser system, you'll also need a laser transmitter that is placed in a fixed position on the job site for the receivers on the machine to talk to. Now, from those masts on the attachment, cords come down and plug into a receiver box that is also mounted on the attachment. And from there, both Topcon and Trimble's offerings, send those measurements to a tablet that is inside the cab for the operator to view. Now, moving on to a 3D system, you'll still have masts mounted to the ends of the attachment, but those masts will either be carrying GPS/GNSS receivers and/or a prism or active target. Now, what's mounted to the masts on a 3D system really depends on what you're using as the positioning reference point. In a 3D system, there are multiple options available to you that provide those corrections or the reference point for your machine's position on the job site. Now, the first option is a base station. Now, that's going to receive positioning signals from GPS or GNSS satellites, and then it's going to radio that position information to the receivers on the machine. Now, the second option is getting your positioning corrections, what would normally be coming from the base station, is getting your positioning corrections through a public or private RTK network, and that's going to be accessed through a cellular or internet connection instead of that base station. Now, using RTK networks can be a way to cut costs and save time through the elimination of that base station. Now, a similar option to the RTK network is Trimble's Centerpoint RTX system. Now, Trimble created this system by creating a network of base stations around the world connected via satellite. And like RTK networks, using Trimble's RTX system means that you don't need a base station to provide your reference point or corrections. Now, unlike RTK, Trimble's system delivers its corrections to your machine via satellite. And access to Trimble's Centerpoint RTX does require a subscription. Now, the final option is a total station, which basically uses lasers and a lot of complex math to create a highly localized positioning system. Now, the upsides are that it provides extremely high accuracy, and you don't have to rely on cellular, internet, or satellite signals to get your positioning. Instead, a total station calculates a machine's position within a site by pinging a target mounted to the machine and then doing a lot of complex math to calculate elevation, angle, and distance in real time. The downside of a total station is that it requires a clear line of sight between the total station and the machine's mounted target. Now, of these solutions, the base station is by far the most flexible. It provides accuracy without line of sight. RTK networks or a solution like Trimble Centerpoint RTX, those are really good for jobs where you have a really high priority to cut costs or to kind of eliminate complexity from the setup. And then a total station is really meant for jobs where a high degree of accuracy is necessary. Now, if you go with a base station or RTK network, that means that you're going to be mounting GPS/GNSS receivers to your blade to receive those positioning corrections. If you receive a total station, you're going to be mounting a prism or active target to those masts. Now, with your receivers mounted, 3D systems also require internal measurement units or IMUs. Now, IMUs measure pitch and roll, and they're installed on the body of the machine and on the blade itself. And just like in the 2D system, once the hardware is installed, everything is communicated to a tablet that goes inside the cab of the CTL. And if you're running an automatic system, well then the system, whether it's 2D or 3D, is going to be tied directly into the CTL's electronics. And that's going to give it the ability to control the height and tilt of the blade. Now, Topcon offers both 2D and 3D systems for compact track loaders with its 2D MC and 3D MC systems. But the company also offers a really interesting product called MC Mobile, which is an all-inclusive 3D service that seeks to provide contractors with a comprehensive workflow that lets you get started and really do almost everything by yourself. MC Mobile essentially supercharges that Topcon tablet that you're using inside the machine. With that MC Mobile tablet, you're able to put it on a pole as a data collector and then use it like a grade rod. Now, this allows any contractor to go out and measure and lay out a job all by themselves instead of needing a surveyor to come out and get things started. Now, from there, you can start putting in the elevations, the boundaries, corners, and landmarks for simple designs. Now, for more complex designs, you're still able to bring in a third party to help you out or make modifications. That's still very easy to do within this system. Now, once you're finished shooting all the points you need, you can then use the MC Mobile tablet to input the desired elevations, cuts, fills, and contours of the project, and then save your design. The tablet then you take it off the pole, it goes back into the cab of the machine, and it becomes your operator interface. Now, like Topcon, Trimble offers 2D and 3D systems for CTLs through its Earthworks platform. Now, for contractors looking for a 2D system with automatics that is also easy to set up, Trimble offers Earthworks Go 2.0. With Earthworks Go 2.0, everything you need for a 2D automatic system comes in one briefcase. Now, you start by installing your laser receivers on their masts, and then you install the comms box and sensor boxes, which are really very simply attached through magnets onto the attachment of the machine, and you're ready to go. Plus, Earthworks Go allows you to bring your own device to use as the in-cab monitor. It works with iPads, iPhones, and Android smartphones or tablets. Now, this setup makes Earthworks Go easy to set up and easy to transfer between machines and attachments. Now, for those who want the full 3D grade control experience with automatics, you can upgrade to Trimble's top-of-the-line Earthworks system. But there's also another level that you should know about, and that's for those who are interested in getting started with 3D and maybe aren't ready for the investment or they don't have the need for fully automatic grade control. Now, Trimble has recently introduced SiteWorks machine guidance for CTLs just for those customers. SiteWorks machine guidance is really an expansion of Trimble's SiteWorks product, and that is its core heavy civil construction job site layout and survey solution. Now, the way the system works is that it pairs a Trimble SPS 986 or a Trimble R780 GNSS smart antenna with tilt compensation. It pairs one of those to a tablet. Now, both of those things are then attached to a rod, and using the rod, contractors can head out and design, measure, and lay out a project without the need of a surveyor. And when the design is done, you can then remove the receiver and tablet from the rod and mount the receiver to the machine and then the tablet inside the cab of your CTL. And that's going to give you 3D indicate machine guidance and grade checking capability. Now, the capability of SiteWorks machine guidance essentially makes this system a 3D indicate system. So it lets you enter into the world of using both 2D and 3D layouts because it does support 2D as well. But it does so without the full investment that automatic machine control is going to cost you. It's also very easy to upgrade from SiteWorks machine guidance into a fully automatic system if you choose to do so. All right, so kind of pulling things all together here, folks from Topcon and Trimble that we spoke with said that contractors that invest in grade control systems for CTLs can easily expect a gain of 20 to 25% in terms of productivity. Now, what that means is that you're going to be getting back no fewer than 2 hours for every 10 that you worked without this system installed. So at a minimum, you're saving time not laying out stakes, not doing additional passes and rework, etc. So in the end, grade control systems on CTLs increase the versatility of these machines even further, and they make them faster and more accurate grading and dozing tools. That means you can do more jobs, scale your business, use less fuel, and most importantly, get home sooner. All right, guys, that's going to wrap up our in-depth look at grade control systems for CTLs. We hope that we were able to answer all your questions in this video, but if you do have any others, be sure to drop us a comment below. Also, if you found this video helpful in researching your next machine purchase or technology investment, do us a favor and hit that like button below, and be sure to subscribe to the Compact Equipment channel here on YouTube, and turn on notifications so that you get notifications for our future videos. And for more content like this, be sure to visit us at our website at compactequip.com, where you'll find tons more information on CTLs, grade control, and everything else you might want to know about compact equipment. Thank you guys so much for watching. We always appreciate the time, and we'll see you in the next one.